Tropical coastal ecosystems are some of the most fascinating and biodiverse in the world, yet they are also the most threatened. Human activities on the land and sea cause impacts on these natural systems that destroy habitats, disrupt ecosystem functioning, and reduce the abundance of marine species. Establishing no-take marine reserves is one way to curb the decline of biodiversity. But determining which areas to protect and how to prioritize management actions in space can be very complicated. So we use the word care to help us remember the fundamental principles for a conservation plan that will protect biodiversity and the livelihoods of people who depend on it. Planning units are the building blocks of any conservation or zoning plan. They convert the world into smaller, more manageable pieces that can be treated separately from one another, sort of like the pieces of a jigsaw puzzle. The first principle of conservation planning is to have a well-connected system. Connectivity in marine ecosystems is important because biophysical processes transport fish and coral larvae and mangrove propagules between habitats. Also, many fish species live in mangroves and seagrass when they are young and migrate to reefs as they mature. While modeling of these processes, such as the dispersal of fish, can be scientifically complex and computationally difficult, a basic understanding of which places need to be connected to others is important for good spatial planning. For example, protecting coral reefs, seagrass, different fish species, and mangroves together enhances the effectiveness of marine reserves for species that depend on all of these habitats throughout their life cycle. This has benefits for both protecting biodiversity and strengthening benefits to fisheries outside of the reserve boundaries. An adequate marine reserve system should contain enough of every habitat and species to ensure that it persists through time. In conservation planning, this is achieved by ensuring that a minimum target amount of the protected habitat types and species are in the reserve system. Some species and habitats need more protection than others. We often refer to these habitats and species as conservation features. A representative marine reserve system is one that captures and protects a sample of all of the habitats and important species present. On top of protecting an adequate amount of each habitat, it is important to spatially replicate the protection of features in a conservation plan. This acts like an insurance plan in case a disturbance or catastrophe destroys part of the system. By placing each habitat in several protected areas, we minimize the chance that all samples of that habitat are lost. A cost-effective marine reserve system is one that meets conservation objectives for connectivity, adequacy, and representation while minimizing impacts on people. This principle helps avoid conflicts between conservation and human livelihoods. Most of the time, we can make small adjustments to our conservation plan to annoy fewer people and still meet our conservation goals. But sometimes, for example, in the case of a species that occurs in only one location that is heavily exploited, compromises cannot be made, and threatening human activities must be relocated. Here is a hypothetical reserve design problem with sites containing conservation features. Some sites are rich, with lots of features, while others have less. Some features occur across many sites, like mangroves, while others occur in fewer sites. Your task is to find the smallest number of sites that conserve all the features. Try to be efficient and choose the smallest number of sites. It looks like Site A might be the best choice because it contains the most features. However, by choosing this, you will also need to select 2 additional sites to conserve every feature. If you look carefully, you will discover that sites C and E actually conserve all of the features at least once. These 2 sites are referred to as highly complementary. Their features are different, but together they conserve every feature. Finding efficient reserve systems that represent all conservation features is not as simple as it looks. Greedy is not good. Imagine solving this problem for the Great Barrier Reef, where there are over 200 conservation features across 17,000 sites. While these complexities are the subject of ongoing research in ecology and conservation science, current systematic conservation planning approaches that use the core CARE principles is our best opportunity to achieve optimal conservation plans for coastal and marine ecosystems.